Solving quadratic equations. Linear equations are first-degree equations, like 2x plus 1 equals 5 or 4 minus 3x equals 2. Quadratic equations are second-degree equations, like x squared plus 2x minus 3 equals 0, or 2x squared plus 3 equals 5x. Right? And these are second-degree equations because our greatest exponent is a square. So quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, or it could be written as ax squared plus bx plus c equals 0, where a, b, and c are real numbers with a not equal to 0. Because otherwise, if a was 0, you wouldn't have a square term. Some quadratic equations can be solved by factoring and using the following basic property of real numbers. So the zero product property. If a times b equals 0, if and only if a equals 0 or b equals 0. This means that if we can factor the left-hand side of a quadratic or other equation, then we can solve it by setting each factor equal to 0 in turn. This method works only when the right-hand side of the equation is 0. So if you have a product that's equal to 0, the only way that's true is if the factors that make up that product equal 0. Solving a quadratic equation by factoring. Find all real solutions of the equation x squared plus 5x equals 24. And if we can factor, it only has real solutions. All right, so let's factor this one. So our first step is we need to set the equation equal to 0. I'm going to write it over here. X squared plus 5x equals 24. So step 1, set equation equal to 0. So this is a good review because it's very important that you know how to factor. All right, so I did not hit that. We just subtract 24 from both sides. So x squared plus 5x minus 24 equals 0. All right, so now step 2. All right, so we want to figure out what two numbers multiply to give us a times c, but add to give us b. All right, and it's easier when a is 1, quite honestly. So 1 times negative 24 is negative 24. Actually, I'm going to put the negative 24 first, and a times c and the b second. All right, so multiplies to give you negative 24, adds to give you the b term of 5. All right, well, that's going to be a positive 8 and a negative 3. They have to be 5 apart. And we'll use factor by grouping. All right, so we have, so that's just factor. Factor by grouping. You can never go wrong with factor by grouping. All right, so x squared plus 8x plus negative 3x minus 24 equals 0. So I simply have rewritten the 5x as 8x and negative 3x. And if you're wondering why, it's because when we multiply, so when we factor, right, we're going to get a binomial times a binomial. Well, when you multiply a binomial times a binomial, you get 4 terms. These were the 4 terms when you multiplied the binomial times a binomial before somebody went and added them together. Right? Because 8x and negative 3x can be added together to equal 5x. So we have the first two are, actually, you know what? I'm not going to rewrite that. I'm just going to do that right here. The first two are, oops, move that over. Plus needs to be between them. The first two are a group and the second two are a group. And then we factor out a common factor. Right? We can factor out an x in the first group. X squared plus 8x divided by x would be x plus 8. Common factor for negative 3x and negative 24 is a negative 3. Negative 3x minus 24 divided by negative 3 would be x plus 8. You can factor out that repeating x plus 8. That's a common factor. They're both multiplied by x plus 8. And when you do, you are left with x minus 3. And we were asked to solve. So now, step 4, let's use the zero product property. And I'll abbreviate. So x plus 8 is 0. Of course, x is negative 8. And if x minus 3 is 0, x is 3. Right? Just add the opposite to each side. And there's the first one. Right? So a little practice on factoring. And that's a nice, easy one. I might not give you such a nice, easy one. Right? Because it doesn't matter what a is, the steps are the same, right? It's what multiplies to give you a times c, adds to give you b. You can rewrite that middle term, and then you just, first 2R group, second 2R group, pull out a common factor, right? And then you'll get that repeating binomial is be one factor, and the leftovers are the other factor. So works all the time, no matter how complicated the equation is. Solving a simple quadratic equation, right? So if we have x squared equals a constant, or something squared equals a constant, we can solve by taking a square root of both sides. But remember, there's always two solutions when you have a quadratic, so don't forget positive and negative, because it doesn't matter whether you square something positive or you square something negative, you get the same answer. All right, so the first one is so easy. X squared equals 5. Take a square root of both sides. Just remember plus or minus on this side. So x is equal to positive or negative square root of 5. That doesn't even simplify. This one is almost as simple. Right? We have x minus 4 squared equals 5. Same thing. We have something squared equals a number. Take square root of both sides. And don't forget on the constant side, right, to take a positive and negative square root. Square and square root cancel. On the left-hand side, so x minus 4 equals positive and negative square root of 5. And then add 4 to both sides to solve for x. Remember that you cannot, oops, lost the 4, sorry. You cannot combine the 4 and the square root of 5, right? It's just going to be 4 plus or minus square root of 5. So that's as much as they get combined. Now, what if it was something, I'm going to add one, because I think some students might be having some trouble with simplifying radicals. So what if we had, and if you are having a little bit of trouble with simplifying radicals, this might be a good one to add to your notes. All right, so let's do something very similar. Let's do x plus 9 squared equals 600, right? All right, so again, take square root of both sides. Don't forget, plus or minus on the constant side. I'm trying to stretch my microphone. Hopefully I'm holding it close enough. But the computer has to be one place to reach, and I need to be another place to reach the board. All right, so square and square root cancel on the left-hand side. That would be x plus 9 equals. Now we can, actually let me give some space. We can simplify 600. Just anything that goes evenly into 600. Hey, how about 6 and 100? 6 is 2 times 3. 2 and 3 are prime numbers. 100 is 10 times 10. There's really no reason to simplify any further with the tens because we have a pair. All right? So 110 comes out, 110 goes away because it takes 2 factors to take a square root. Right? A square root is what multiplied by itself, right, equals what's in the radicand. So the 10 can come out of the radicand. Oh, don't forget your plus and minus. But the 2 and the 3 cannot. They do not have a buddy. All right, so this is going to be plus or minus 10 square roots of 6. So we can simplify that radical. Again, we're going to subtract 9 from both sides. X equals negative 9 plus or minus 10 square roots of 6. Do not make that 1 square root of 6 and negative 19 square roots of 6. Right? Those are not like terms. One is multiplied by the square root of 6 and one is not. Right? So if you have something in a radical that can be simplified, right, then you need to simplify it. Right? So it's essentially the square root of 600, right, where's the other 0? Didn't pop up, is equal to the square root of 6 times 100. 100 is the largest factor that's a perfect square. So if there are any factors that are perfect squares, then we need to simplify them. 5, of course, does not have any factors that are perfect squares. It's a prime number. Right? So make sure that if you have a number that can be simplified, in other words, it has a factor that's a perfect square, that you take the square root of that factor. Okay? And you can either use the buddy method, or if you look at it and you go, hey, that's 6 times 100. And I know 100 is a perfect square, and there's no more perfect squares than 6. That's fine. And you can then just do it this way here, right? And then rewrite that as 10 square roots of 6. Right? Whichever way works best for you. Right? So I wanted to get one in there with simplifying, and that would be a good one to put in your notes. And I can pause, right? Or you can pause me if you're watching the student paced version. All right, let's look at completing the square. Now, first of all, I want you to look over on the right-hand side. There's a diagram there, and it kind of shows you completing the square. And you might look at that and go, maybe that makes perfect sense to you. This is the x squared. Together, this is the x, right? So this is half the x, and this is half the x, right? Because it's b divided by 2. So whatever actually I shouldn't say whatever. And I mean, when I say half, I mean half of b as well. So together, the b divided by 2 and the b divided by 2 together, right, would be b. Right? So if we're multiplying, this is half of b times x. So this part here is b divided by 2x. And this part here is b divided by 2x. And this right here is our c. That makes it a perfect square. And that may make perfect sense to you, or it might not make perfect sense to you. But I am going to do a visual in class with a model. And after I do the visual with the model, that diagram will make perfect sense. All right, so to make x squared plus bx a perfect square, there is a magic number. And in Algebra 2, I do a visual. And that visual, I don't even think I can draw it. Let's see how badly I can draw. Oops. Sorry, I didn't mean to put a B. That is a B. I wanted to put a 2 under here. So this thing here, this is its stinger. Maybe if I did it in yellow. And it's buzz, buzz, buzz. Let's put some stripes on it. Might be striped? Yes, I think so. All right, that is b divided by 2 squared. Buzz, 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 divided by 2 squared. And that's the magic number that makes our x squared plus bx a perfect square. And remember that addition property of equality, you can add anything you want to an equation so long as you add the same thing to the other side. It will still balance. All right, so and I'm going to demonstrate, by the way, that diagram with actually both of these problems here. All right, I'm going to solve them using completing the square on the video. But before I do that, I'm going to solve them with the model. I'll pause the tape and I'll solve it with the model in class. All right, so now that you've seen me solve it with the model, let's solve it algebraically up here. All right, so we have x squared minus 8x plus 13. Our first step is to move the 13 to the other side because it was of no use anyway. right? So it's going to be equals negative 13. All right, and so I'm going to, so in class, I'm going to just push the 13 blocks aren't going to be there. I'm just going to deal with the x squared minus 8x. So you can see what's the magic number you would add. And hopefully, you know that that magic number is going to be half of b, right? So that's going to be 8 divided by 2, because b is 2, because b is 8. If you look up at the top, up at the time there, you can see why I'm a little bit tired. And there goes my light. Now I'm in the dark. So we have x squared minus 8x plus 8 divided by 2 squared. That's the magic number that makes us a perfect square. Equals negative 13. I should have given myself more space. I'll just do b underneath. Right? And I can add, or maybe way over to the right. And I can add anything I want to an equation so long as I add the same thing to both sides. On this side we have 8x minus, x squared minus 8x plus 8 divided by 2 is 4. 4 squared is 16. On the other side we have negative 13 plus 16. Now this will always factor, and I'm going to write how it's going to factor. It's always going to factor to be x plus or minus whatever this sign here of b is, b divided by 2 squared. Right? There's going to be 2 of them because it's a perfect square, and it's always going to be b divided by 2. So that means x squared minus 8x plus 16 is going to factor to x minus, now what's b divided by 2? It's the thing we squared. 8 divided by 2 is 4. So this is going to be x minus 4 squared equals 3. Right? And if we, here this just a little, just to show you, yes, that's really, just in case you had doubted me in any way. X times x is x squared. Negative 4x plus negative 4x is negative 8x. Negative 4 times negative 4 is 16. So you see that x minus 4 squared is indeed the same as x squared minus 8x plus 16. And you don't have to write that. Now that I have a something squared equals a constant, we can solve it just like we did on this page. It's just like this one right here, like b. Right? We're just going to take a square root of both sides. Not hard at all. Right, so we have the square root of x minus 4 squared equals plus or minus the square root of 3. Square and square root cancel. This is x minus 4 equals plus or minus the square root of 3. And the 4 goes in front, right? These are two separate terms. X equals 4 plus or minus the square root of 3. They can't be combined any more than that. All right? Let's do the same thing on the other side for the other equation. Now we have one other thing to do here, and that is if a does not equal 1, divide both sides by a first. All right, so I'm going to have to divide everything by 3. Of course, a is that coefficient in front of x. Excuse me, x squared. So a here is 3, and 3 is not 1. So we have to divide by 3 first. Right? Otherwise, this won't be a perfect square. If there's any coefficient on x squared, it's not a perfect square. So we have to divide. And in this case, it's nice. It divides evenly. Wouldn't matter if it didn't divide evenly. All right, we could deal with it even if it does not divide evenly. So this would be x squared minus 4x plus 2 equals 0. All right, so now we can do the exact same steps as we did before. We're going to move the constant because we can't factor it anyway. There's nothing, by the way, neither of these were factorable. There's nothing that multiplies to give you 13 and adds to give you negative 8. 13 has 2 factors, 1 and 13. Well, it has one set of factors, 1 and 13, that's it. All right, and negative 1 plus negative 13 is negative 14. And the same thing here, this wouldn't factor. There's nothing that multiplies to 2 and adds to negative 4. All Right? 2 has one set of factors. Right? 2 and 1. All right, so we're going to subtract 2 from both sides. So we have x squared minus 4x equals negative 2. We're going to add the magic number, and that magic number is b divided by 2 squared. So we have x squared minus 4x plus negative 4 divided by 2, because b is negative 4 squared, equals negative 2 plus negative 4 divided by 2 squared. Right, so we have x squared minus 4x plus, right, so negative 4 divided by 2, that's 2, negative 2, and negative 2 squared is 4. So this gives us on the left-hand side, we can factor that to x. The sign here is a subtraction, right? So it's going to be a subtraction again. And then half of b, right? b was negative 4. Half of negative 4 is negative 2. So x minus 2 squared equals 2. And then we can solve by taking a square root. Now these two examples were actually pretty easy examples. There was no odd numbers. Square and square root cancel. So maybe let's add 2 examples. One with some simplifying, and well, actually we'll add 1 example. We'll just make it a little harder. And that's going to be the end of this tape. I'm just going to do one more completing the square example. And this time we're going to have maybe an odd number, something to simplify. All right, so two x squared plus 10x see if I can come up with something that we have to simplify. Well, I'll do my best. 40 equals 0. All right, let's try that. All right, so our first step, we have to divide everything by 2, right? So divide all terms by a. And if you want a harder example for your notes, this would be a good one. Hopefully there's something to simplify. But at least we're going to have an odd number for b. All right, so that'll be x squared plus 5x minus 20 equals 0. All right, so now we're going to move the 20 to the other side because it's of no help anyway, because there's nothing that multiplies to give you negative 20 and adds to give you 5. All right, so we have x squared plus 5x equals 20. All right, so isolate the constant. And these are I'm actually writing out the steps because I have more space on this page. All right, so now we're going to add b divided by 2 squared. And b in this case is 5. Not as pretty, but it's okay. All right, so we have x squared plus 5x plus. All right, so 5 halves squared, don't make that 2.5. Although at least that's not so bad to square. That would be 6.25. But let's just leave that as 25/4. Just get in the habit of leaving it as a fraction because it will be easier to deal with in the long run. All right, and then this is 25/4, but I can't combine that with the 20. So I need to change the 20 so it has a denominator of 4, right? You can only add fractions that have the same denominator. So that means so 20 is technically 20 over 1. If I multiply the denominator by 4, I got to multiply the numerator by 4. So that's going to be 80/4. And if we were to divide 80 by 4, we get 20 again. Well, this will simplify a little bit anyway. So on the left-hand side, this factors very nicely to x plus half of b. What's half of b? Sitting right there was the thing we squared. 5 halves. So you see, it's really not very hard to factor. It's the thing you squared. all right, equals, on the other side we have 105/4. So we will be able to simplify a little bit, but it's going to be a perfect square because 105 is not going to simplify. 105 is 21 times 5, or 3 times 7 times 5. 3 prime numbers. So, but at least I got an odd b in here. All right, so we're going to take a square root of both sides. And you can think of that fraction as a quotient of square roots, right? So the square root of a quotient is the same as the quotient of the individual terms in the fraction there. So square and square root cancel. This is x plus 5/2. On the other side, teeny weeny bit of simplifying. That denominator is a perfect square, not the numerator, but just the denominator. So now we would, oh, I forgot to keep writing my steps in. So we added b divided by 2 squared, and then we simplified, and then we factored, and then we solve using square root property. And then finally, isolate variable. Got to write on the other side. So the last thing we're going to do is subtract 5/2 from both sides. X is negative 5/2 plus or minus the square root of 105 halves. All right? You can't really combine the terms unless you like this better. All right, so unless you like that better, all over one denominator. Oh, no. I don't know why it does that. All right, good enough. There we go. So unless you like it, over one denominator, they're equivalent expressions. That's the most simplifying you can do. And that's going to be the end of this podcast because I'm already at 27 minutes, and that's long enough. All right, thanks for watching. Bye for now.